right? So I think we have discussed about transaction atomicity in today's class, recoverable schedule, non-recoverable schedule, cascading rollback, and cascadeless schedule, right? So I want one of you to look into it and explain it again, so that I think it's easy for others to follow. So can anyone define a recoverable schedule and non-recoverable schedule?
A recoverable schedule is the one where if there are two transactions, Ti and Tj, if Tj is reading a data item which is written by the Ti transaction, then the commit operation of Ti should appear before the commit operation of Tj.
Right.
That
so
is, yeah.
That is a recoverable schedule.
Yeah.
Correct. Continue, Saloni.
Yeah, that is a recoverable, and then I should say non-recoverable schedules, right?
Right.
Where this, like, the commit operation of Ti does not occur before commit operation of Tj. So with that, you gave an example of the partial schedule.
Right. So this slide is an example for non-recoverable schedule, right?
Yeah.
So you have a transaction, two transactions running concurrently, T6 and T7. Transaction T7 is going to read a value of data item capital A that is being written by transaction T6, and it commits at once. So over a point of time, if T6 fails, what happens? T6 has to be aborted. However, you will not be able to undo the transaction T7.
So T7 has to be aborted anyway.
Yeah. So commit should be done previously for it to be recoverable.
Right. So whenever you have concurrent execution of the transactions, you need to design it in such a way that it should be a recoverable schedule, right? So for a pair of transactions, Ta and Tj, which are executing concurrently, such that Tj reads the value of data item that is being previously written by Ti, the commit operation of Ti should appear before the commit operation of Tj. So this is the property of recoverable schedule. And cascading rollback, again, it's quite simple, right? So someone can try it, right?
Yes, sir. When some commit fails, and then if a transaction fails, you have to roll back the changes for it. And if some other transaction is dependent on that particular transaction, you have to roll back that change as well. So it's like a domino effect where if you roll back one change, you have to roll back the changes that are dependent on that particular change as well.
Right. So this is known as cascading rollback, right? So here in the slide, transaction T7, T8 has write a value of data item capital A that is being read by transaction T9. And over a period of time, T9 has write a value of data item capital A that is being read by transaction T10. Right. So they are dependent. So they are sharing the same variable, or they are referring to the same variable. Over a period of time, transaction T8 fails. So you need to abort the transaction and you need to roll back the transaction T8, right? So since transaction T9 is dependent on T8, again transaction T9 has to be rolled back, and the transaction T10 is dependent on transaction T9, right? So it has read the value of data item capital A that is being written by transaction T8. Again, it has to be rolled back. So hence a small failure or a single failure, it has lead to a sequence of rollback operations. It's known as cascading rollback. So what do you mean by cascadeless schedule? Right. So this is the definition for cascadeless schedule, right? So you have a pair of transactions, Ta and Tj, such that Tj reads the value of data item capital. Tj reads the value of data item that is being previously written by Tj reads the value of data item that is being previously written by Ti, then the commit operation of Ti should occur before the read operation of Tj. We say that it's a cascadeless schedule, right? So these things you should be familiar, right?